Okay, now we'll get deeper into Lab 2. So in Lab 2, the user will type as input a digit and then a string to convert. And because of SASM, and we're just right now not very far into assembler anyway, it's going to look pretty weird. So if, for example, the example which is at the beginning of your program is they're going to convert a string, oh, it happens, and we're going to imagine that they want to use the encryption key of just the digit 5. So the encryption key is just one digit, and okay, so what will they actually type? They'll actually type a 5 and then the string to convert. Excuse me, that was just an O. So this is the input. Okay? And among the input, this 5 here is the key. And here is the string. Okay? So we're going to use the key, which is a 5, to convert the rest of the string. All right. Now, the other video showed you how to take care of the 5. Now we're going to ask, how do we handle the string? So, okay. So ultimately what this program is going to do is it's going to print the original string and the encrypted string. So it will print originally, and then it will print what you typed in. And then it will print now it is, and then it will print the munged encrypted string. Okay. So we've seen before we have a data section. The data section contains, for example, these DB, defined byte commands. And DB says what? Here's a label attached to this part of memory, DB, and then here's some bytes. Okay? So here's a bunch of ASCII character bytes, and then a 0 because our strings end in 0, just like in Lab 0. Then we have another label attached to this chunk of memory, and at the beginning of this part of memory, and here's a bunch of ASCII bytes followed by 0. Okay. Now in Lab 0, we had some 5 spots up here where you could put A, B, C, D, E, right? And then you converted them into capital A, B, C, D, E. Right? Okay. We don't want to actually put a bunch of zeros. What we want to do is we just want to reserve a chunk of memory and put a label at the beginning of a piece of memory and say, this is where my data is going to go while I'm running. So data which shows up while I'm running is going to go in this memory here. It's an uninitialized piece of memory with a label on the top. Now for reasons which are lost to the mists of history, that section is called BSS, or .BSS. Why? I don't even remember. It happened probably before I was born, which was, back when the dinosaurs, pterodactyls, were still flying. Okay. Anyway, the BSX section contains chunks of memory which are not initialized but have labels on them. So from stir will be the original string that people typed. To stir will be the encrypted string. Res-B is like DB, except that res-B means reserve some bytes, but I don't care what's in them. Res-B 100 bytes. Reserve 100 bytes. So we could have strings which are 99 long plus a 0 at the end from the from string that people type and the to string, which is the result, right? And then we have your text section, which has your program in it. So this BSS is new for this lab. All right. Now, going over to your code. Obviously, we need a loop, right? And we're going to process a character at a time. The idea is that we're going to get our characters by reading. So there's going to be a getChar macro inside your SASM code, which is going to read one character from the input into AL. Okay? And this is a loop. Next is at the beginning, the label at the beginning of the loop. So ultimately, down at the bottom, we're going to jump back up to next. When we get the character, the first thing we're going to do is we're going to put it into from string. How do we do that? Well, we needed an address. Here's ESI. So the ESI register will contain the address within the BSS section. So ESI is going to start out with this address from this label. EBX is another register that will start out with the address of this part. If I move AL like this, if you'll remember, then this means go touch the memory that ESI has the address of. So over here, it'll put AL, move AL into that first byte. And then we're going to increment ESI, and we'll get to the next byte, the next byte, the next byte, right? Okay. So that's the first thing that's going to happen, okay? Now, the next thing that happens, it turns out, is that you need to figure out whether or not you're at the end. So there's going to be an if, okay? So if this was a new line character or a binary 0, all right? So how do we compare it to a new line character? A new line character is what? It's a 10 or a hex alpha. Okay, so a new line character is 10. So how do I compare? You should remember. And if it was equal to 10, we want to break out of the loop. So this is, again, our ifs are backwards, right? So if it was equal to 10, go out. Instead of if it's not equal to 10, do some stuff, okay? Okay, out of loop, whatever you want to call it, okay, some label. Got it? The next thing we're going to want to do is we're going to encrypt the byte. We're going to encrypt it by XORing. And I'll let you figure out what that is. And then after we XOR it, we're going to move it. And we're going to have them move it into toSTR over here. So toSTR's register is EBX. We want to get it into the memory, right? So this is going to involve an EBX, right? Somehow this is going to be in here. We know that because EBX has the address, and we've got to go into the memory. And then we're going to want to do what? We're going to increment. We're going to increment the two registers, ESI, EBX, so that we're marching along the bytes here, the byte, 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 byte. And then we're going to want to jump up. Okay? That isn't the whole story. That's the main story. There's some other stuff going on. Okay? So, for example, suppose you were encrypting with a 5 and your letter was Z. So Z is equal to, in hex, 7 alpha, which is in binary 0111 1010. And now if we XOR that with a 5, what do we get? 0 XOR 1 is 1, 1 XOR 0 is 1, 1, 1, and then 1, 1, 1, which is 7F. If you look in your ASCII table, you'll discover that 7F is a delete character. It's not a printable character. So you're going to have an if in here so that if you accidentally encrypted a character and got a delete, you don't want delete as your resulting encrypted character. You'll put the original character back. All right? So there's stuff in here besides what I just wrote out. Got it? Okay. That's enough. End of this story.